This question is asking us to graph the lines on the grid below, the lines that would go along with these two given equations here. And the tip above says to repeat this question multiple times by clicking on New Version until you've seen all three types of relationships, including parallel, perpendicular, and neither. So, in each version of this question, you should be given two equations that you can graph both lines on the grid, and then determine whether the relationship between the two lines is that of parallel, meaning side by side and never touching, never intersecting, or perpendicular, which means intersecting at a perfect right angle or 90-degree angle. And neither means that they would be intersecting somewhere, but they're not at a perfect right angle. All right? So let's go ahead and review how to graph a line. So these two equations are given in slope-intercept form. What slope-intercept form does for us is allows us to quickly identify both the y-intercept as a starting point, so that would mean wherever the line crosses the y-axis or the vertical axis, and then the slope, which is always a coefficient in front of x, and that will tell us the rise over run or the steepness of the line. So we would start from the y-intercept point and then use that slope from there up and over, or maybe down and backwards, to get to a second point. And once you have 2 points, you can connect them with a straight line. So let's start with the top line. The top line, and just so we are all on the same page, I know this is something you've probably learned before if you're in this class, but what is slope-intercept form? Let's make sure we all know what that is. So slope-intercept, form of a line or a linear equation. Okay, that's what we mean. Slope-intercept is when y is solved. It's sorry, the equation is solved for y, or in other words, y is on one side of the equal sign all by itself, and then everything else is on the opposite side, and it's simplified. The number that is just a constant with no variable attached would be the y-intercept, and it always has the ordered pair with a 0 for x and then some y value that we just call b in general. Then the slope is the number that is attached to x or next to x, and that is your rise over run, your slope. More formally, we say it's the change in y over the change in x. So the triangle here means change in. It's a delta, a Greek letter, delta. So this says change in y divided by change in x. So that's why we say rise, because rise is the difference between two y values, so the vertical difference, and x is the horizontal distance between the 2 points. So we call that the run. Okay, so sometimes it's written like this. This is probably how you learned it. y2 minus y1 divided by x2 minus x1. So what that's saying is when you have 2 points, x1 and x1 and y1, and x2 and y2, you would just put the values into that formula. Okay, but we're not actually going to be working really with that formula. We're just going to be taking the y-intercept form that's given here and using it to do our graphing. So we're going to start with this first line. We're going to use green for this one. And since -5 is a constant all by itself with no variable, that would be our y-intercept. So we're going to put a point right there on the y-axis at -5. Next, we are going to use the rise of 7 and the run of 3 to get to a second point. So from the point that I've already made, I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7. And then I'm also going to do a run of 3. So I'm going to go to the right 1, 2, 3. So now there I can make my second point and then connect them. And unfortunately, with the with the writing on screen, it's a little difficult for me to make it perfectly straight. So we have to use our imaginations there. I can also use a line tool. So let's try this. Let's say from here. Is it going to work for me? There we go. And then what you want to do is really imagine that this is going on in each direction without ever ending. So what we usually see are arrows or arrowheads on each end of the line, just to show it's not necessarily stopping, it's just going on and on and on. So that would be one line. And then we can do another line. So let's do the second equation in blue. Now, if you notice, there is no constant value. It's just blank. So I'm going to put a 0 there just because we can. I mean, 0. Adding 0 to anything doesn't change it, right? So we can assume that our y-intercept is actually at the origin at 0, 0. Or in other words, on the y-axis at 0. Now again, we have a slope of 7/3, which means we're going to go up 7 and over 3. Okay, so if I count up 7 from 0, I get to 7. Right, so let me do a little erasing here. Get rid of this yellow I'd used before for tracking my up and overs. And now here's my blue point again. And then I'm going to use yellow just to show me counting up and over. So I'm going to count 1, 2, 3, 4, 5, 6, 7. And of course, since I counted up from 0, I'm landing at 7 on the y-axis. And then I'm going to go 3, a run of 3. So 1, 2, 3. So there I will put my second point and then connect those with a straight line. Now, what we should notice is that when we have a slope, or I'm sorry, when we have two equations with the same slope, what ends up happening is we get parallel lines because they are, they have different intercepts. They have to have different intercepts, by the way. If they didn't have different intercepts, what we would find is that they would be the exact same line, and that just doesn't fit the definition of parallel, because parallel means never intersecting. So any two equations that form the same line would be intersecting literally everywhere at every point, and so that would not be parallel. So parallel means same slope, same steepness, in other words, but they are intersecting the y-axis at different places.